Okay, so what we're looking at today, the whole idea of what we're looking at is fairly easy. So what you need to do is be sure to read carefully as far as these theorems are concerned, and then don't make it harder than it's supposed to be. So for example, if we read right here, it says, if a point lies on the perpendicular bisector. So the thing we're looking for is, if we look here and here, that means that it's bisecting. Here we have the perpendicular piece. So if a point lies on that perpendicular bisector, the conclusion is that it's going to be the same distance from your endpoints. Okay, so if you look at this, it makes sense because if you think about our triangle congruency, we've got this shared side in the middle, and we've got a side here, and then we've got our 90 degrees here and here. So we actually have a case of side angle side, and then from that, we can conclude that those two pieces, AC and CB, are congruent because of CP, CTC. But what this does is this shortens it a little bit. Okay, so if we have the perpendicular bisector, then any point on there is equidistant from the side. So our conclusion would be that AC is congruent to CB. Again, we can go back to the congruent triangles that we've done prior. If we look at the next piece, it's their opposite. So if you notice, we have this word converse again that we've seen in the past. So if we have a point there, equidistant from the endpoints of a segment, then we know that this line here is a perpendicular bisector. Okay, so if AC is congruent to CB, then we know that CD is perpendicular to AB, and we also know AB is congruent to BB. So really what we're looking at is we are now taking this information and we can conclude that in the converse. All right, so here's the application piece of this. If we look at this question, we can recognize, again, we have this shared side, so we have congruent triangles, making those two pieces, 7x plus 24, equal to 13x minus 48. And then we can just go ahead and solve. So when we look at this, we get 72 on the left, 6x on the right, and when we divide, we get x equals 12. That's it. Same concept on the second one. If we have the value, or find the value of x, here we have the perpendicular bisector here going on, and so now we can go ahead and say that we have 17x minus 3 equals 9x plus 13. And so you have 8x here, 16 here, x equals 2. So going back to our basic algebra. If we look at the next couple examples, it's more of the same. And so when you look at number 3, again, we have that perpendicular bisector, so we know that those two pieces then are going to be equal. When we solve, we get 3x on the left, 27 there, we get x equals 9. The only thing we have to be careful of is we have RS is what they're asking for. So now we need to substitute into 4x plus 5. And so then we get 36 plus 5, which we have 41 for a value of RS. If we look right below, similar concept. Okay, we have another pair of things that are going to be congruent. So 5x minus 11 equals 3x plus 17. So we have 2x here, 28 here, x equals 14. But again, it's not asking you for x, it's asking you for AB. So what we would need to do in this case is we would go ahead and plug in. So we have 5 times 14 minus 11, which 5 times 14 minus 11 will give us 59. But notice that is just from A to D. So if we plug it in for DB also, notice we should get the same thing. So if we do 3 times 14 plus 17, we do get the same thing. And then to figure out the whole length, we just add those two together. So AB is going to be 59 plus 59, which is going to give us a value of 118. So take a minute, try out the two on the right, try out number 4, try out number 6, and let's see where we are. Okay, moving on to the second concept, all right, the angle bisector theorem. Again, if we read through this and think about our congruent triangles that we've done in the past, this makes a lot of sense. If a point is on a bisector of an angle, so here we have the bisector, and the reason we know that is we have congruent markings here. If a point is on that bisector, then it's equidistant from the sides of the angle. So think about the shortest distance from that point to the side makes a 90-degree angle. Same thing here, shortest distance from here to the side, 90-degree angle. So if we think about this in terms of our triangle congruency, we've got these angles are congruent, we have a shared side here, and we have congruent angles there. So those two triangles are congruent, by angle, angle, side, thus making these two pieces equal or congruent. So we know that those two lengths are going to be the same. So BD congruent to DC is going to be equidistant from those sides. Notice the second one, similar concept, but it's the converse. So the thing that we are starting with in this case is that we have the congruent pieces here. We also, again, have those 90 degrees. We have the shared side. So now we're looking at those two triangles being congruent by HL. And if we know that, then we can say that we have an angle bisector there. So we would have AD bisects angle BAC. So again, we can kind of use those triangle congruencies that we've done in the past. So if we look at our examples, finding the value of x, again, we could just say that those two triangles are congruent. And once we have those two triangles are congruent, so are those pieces. So 4x plus 30 equals 9x minus 5. So when we subtract, we get 5x, we get 35, x equals 7. Again, I do the algebra fairly quickly because hopefully that's something that we are very familiar with at this point. Number 2, we have those triangles. Again, they're congruent by HL, and so therefore those two angles are also going to be the same. So when we set those two equal, we get 3x here, we get 30 on the left, so x equals 10. All right. If we look at the next set of examples, if we look at the first one here, again, we have those triangles are congruent, so AD and DC are the same. So we set them equal, subtract, add the 4, so we get x equals 5, or 3. The only thing is we're looking for AD. And so when we look for AD, we now need to go ahead and plug it in. So 13 times 3 minus 4 will give us, will give us 35 for our value of AD. If we look right below it, number 5, very similar concept. Okay, those two triangles are congruent by HL, so those two angles will also be the same. And so again, we're just going to set those two equal because they are equal. So when we solve, when we divide by 3, we get x equals 19. But again, it doesn't ask us for x. It asks us actually for this entire angle. And so when we look at this, we're going to plug in 19 for the x. So 2 times 19 plus 20 will give us a value of 58. And then 5 times 19 minus 37 will also, I typed in something wrong. Let me try again. 5 times 19 minus 37 gives us 58. Now, here's the thing. I knew I typed in something wrong because when I typed it in, that those two were not equal. They should be. All right, so then the measure of the angle FGH is going to be those two angles added together. So 58 plus 58 is 116 degrees. All right, now go ahead and try out those other two, and guys, that's it. So we can always kind of connect these back to our triangle congruencies that we've done in the past. Now, with that, as always, ask questions if you have them. Guys, hopefully that was pretty straightforward today. Thanks a lot. Have a good one.